So today we're talking about spheres, and you see spheres every single day. Anything that is a ball, basketball, baseball, Earth is a sphere. So we see spheres all the time. Let's go over some vocabulary. There's just a few vocabulary terms at the top. Did you bring that because you were doing spheres today? Oh, just coincidence? It's a tennis ball. But he's going to put it away. Oh, no, 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 no. Nope, 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 nope. Just put it away.
No means no.
Okay, so sphere. Sphere is like a three-dimensional circle. So it's a set of points that are all equidistant from something called the center. So if you think about this in real life terms, Earth is a sphere, and the center of Earth is the core. And if you've never seen the movie The Core, you should see the movie The Core. It's a really good movie. What? Oh, I thought you said, will that movie be on our test? I don't remember. Trey, were you a Boy Scout?
Was I? Heck no.
I was.
What's wrong with you?
I was a tennis one.
Okay, a radius, just like on a circle, goes from the center to a point on the sphere. So there are infinitely many radii inside of a sphere, lots of them. Anything that goes from the center out to a point on the edge of the sphere.
So you were a Boy Scout.
Eagle Scout. What troop were you in?
No, we're not.
Troop 365.
Did you really get your Eagle Scout? That's a huge accomplishment if you really did.
It's like,
Really?
Yes.
that's
the highest the high, and my high school boyfriend became an Eagle Scout, and that's like, I've never seen somebody go through so much before for something like it's crazy. Like, they have to go through a lot. It looks really good on the resume
Is it
too.
like the Navy SEAL training?
I mean, not quite, Jake Walker. Okay, a chord. This one's a little bit hard to see two-dimensionally, like quite hard to see two-dimensionally. A chord starts and stops on the sphere, but you'll see, like, on that picture, it's just really difficult to see because you can't see the edges of the sphere. So if you imagine like a stick inside of what? You're fine. No. If you imagine, if it's important to leave a message. If you imagine like a pole going through a basketball, okay, that would be a chord if it started and stopped on the edge of the basketball. And then the diameter is a chord that contains the center, so it goes right through the middle of the sphere. So like, look at the chord. That's hard to see because it doesn't look like it's even touching the edges of the sphere, but you have to imagine like maybe it's coming from the back up to the front of the sphere, and you just can't see those edges. Okay, and then the last term here, I like the last term because I have a real life example for it. A great circle is a plane intersecting a sphere containing the center. So basically it cuts a sphere in half, creating half circles, which are called hemispheres. We don't call them semispheres, hemispheres. So if you think about planet Earth, who thinks they know what the great circle of planet Earth is called? The equator is exactly right. The equator is an example of a great circle. It cuts our Earth in half into a northern hemisphere and a southern hemisphere. So the equator would be like an example of a great circle for Earth. That was it.
I mean, like something that happened in your life.
No. Like Earth is real. It's a real sphere. The equator is real. It's a real great circle. Okay.
You never know.
You're right. We never know.
I don't know if you're on what? I said your trip was in Texas. I looked up 365. It says Texas.
So you're not.
Did you really?
Yeah.
That's really funny. Okay. Hold on, guys, let's get this done quickly so we can have more time. Surface area of a sphere. Now, this is an estimate. So they gave you an example here of a baseball, or like a tennis ball has the same makeup. If you were to take apart, like unstitch the outside of a baseball, this is what you would sort of be looking at. Well, it's sort of like 4 different circles, give or take a few units here, because it's not a complete circle, number one, and there's some covering in the middle. So they've sort of estimated the surface area of a circle as being 4 circles put together. So the area of one circle is pi r squared. So to complete the surface area of the sphere, we take that circle pi r squared times 4. And that is your formula for surface area of a sphere. Now they use capital S again. I use SA. It doesn't really matter as long as you understand S stands for surface area. So for spheres, all you need to know is the radius. That's literally it. You don't have a height of a sphere, just a radius. So if you have at all today a problem where they give you diameter, you have to cut it in half. There's no way to do the problem with the diameter. Kind of like cones.
Sugar cones.
Okay? All right, here we go. A is pretty straightforward. If you don't have a calculator, I want you to have a calculator in front of you. The radius is 8. Your formula for surface area is 4 pi r squared. So 4 pi 8 squared would be our surface area. We'll leave it exact and we'll get it as a decimal. What's 8 squared? 64. 64 times 4 is, okay, turn on answer. 64 times 4 is, who can raise their hand, Jace? 256. So we can leave it as 256 inches squared, or we can type it in and get a full decimal. So who can raise their hand and tell me what 256 times pi is as a decimal? Seth? Good. And like I said, you might be able to type all this in at once. I would just be careful because there are some calculators that they don't use order of operations correctly. Don't talk. We're going to actually skip to the third example. Okay, here's your formula again. You only need the radius. Who can raise their hand and tell me what the radius of this circle would be? Luke? 20, because the full diameter is 40, so then half of that would be 20. Very good. So when you plug that into your formula, 4 pi 20 squared. You don't want to use 40. That'll be too big. 20 squared is 400. (400) times 4 we can do mentally. Are we writing this down, Jake Walker? Probably be wise. What'd you get, Jace? 1600 pi, so we can leave it as 1600 pi feet squared, or 1600 times pi. Big number, that's right, because you're taking 1600 times 3.14 something. Luke, what are you getting?
It is 5,026.5.
Like that? Like that? Good. All right. The second one, let's look at that one. You cannot do surface area unless you have the radius, right? Now they give you the circumference here, but they don't give you the radius. Does anybody have a thought for how we could find the radius if they give you the circumference? Did you think through your thought before you said it out? Okay.
Thinking.
Okay. What's your thought?
I'm thinking right here. So like 360 is
That's arc measure, which is different than circumference.
So we put 360
There's no 360 involved. Good thought. But arc measure is different than circumference. Corinne?
Would 12 be, like, would you divide by 12 not to be the radius? Is it like,
Divide what by 12?
divide in half, and that would be 6?
Well, this is not the diameter. This is the circumference.
The circumference is
Oh, circumference equals.
Okay, what's the formula for circumference? Formula for circumference.
square.
Oh, come on. That's area. Pi r squared is area. What's circumference? Two pi r. Thank you. So since circumference is 2 pi r, I can take the 12 pi and plug that in for circumference, just like we did on the test part A, and then solve for the radius from there. So how would I get r by itself? Who can raise their hand and tell me, and not blurt out loud? How do you get r by itself from here? I see people writing, so I would love it if they could vocalize what they're writing down. That would be awesome. Jace? Not minus. Divide by 2 pi. Okay, then we get r by itself, and then what cancels on the left side? Pi's, and then 6, or 12 divided by 2 is 6. There's your radius. So if they give you the circumference, you're going to solve it the way we solved it on test A, and set it equal to 2 pi r, and then find your radius. Now I'm ready to plug it into 4 pi r squared. 4 pi r squared. Six squared is 36. It's 36 times 4. I've heard from Jace. Let's go, Andrew, what's 36 times 4? What is it, 144? So we can leave it as 144 pi, or 144 times pi. Let's go, Tanner, what's 144 times pi, the nearest 10?
452.4.
You can square it. So either one's correct. You do not have to put both answers. Just either or is great. But I still see people leaving, if you're going to leave it in terms of pi, you have to put a pi. I keep seeing people leave that off. And I don't take off on the homework, but I'll take off on the test for that. Okay, questions on surface area? Actually, we have 2 more problems. All right, these 2 problems, they give you the surface area, and then they ask you to work backwards to find the radius. So here's your formula for surface area, 4 pi r squared. They're giving you the surface area, so it makes no sense to plug it in for the radius, but we can plug the 30 pi in for s, and then solve for the radius. What would my first step be here to get the radius by itself? Divide by 4 pi. Okay, the pi's will cancel. 30 divided by 4 is a decimal. 7.5, I think. Now, that's r squared. So I still get this confused a lot too. Seth, how do we get r by itself? Square root. Don't divide by 2. Dividing and squaring are not inverse operations. Square root of 7.5 is what? 2.75? 74? Like that? Okay. Meters?
That's it, right? So wait, when we cube it?
It's not volume. Nope. Okay, number 2, we're going to solve the exact same way. Jake Walker, wake up. And then in the end, they ask for the diameter. There's no way to just like jump straight to the diameter. We have to solve the radius first, and then we'll find the diameter after that. So we're going to solve it the same way we solved the last one. Here's your surface area formula. Our surface area is 20.25 pi. Okay. DJ, what was our first step here again to get R by itself? Say again? Divide by 4 pi. We get R squared alone. Pi's cancel. 20.25 divided by 4. Somebody help me out there.
5.1.
Go ahead. 5.1. And then square root of 5.1. Andrew? 2.3 would be your radius, centimeters. Oh, I already messed it up. What? How'd you get 4.5? Okay, double it, but I don't agree that it's 4.5. You must have rounded differently than we did. Good. Whoops, sorry. Radius is 2.3, and they asked for the diameter in the directions. So you would want to go ahead and double it. Questions on surface area? All right, all we have left then is volume. Volume is a little bit of a weird formula, so make sure you're paying attention because I see this happen every year. Volume is 4 pi r cubed, not squared, divided by 3. And every year I have people square r. You'll get a formula sheet, but you should still be aware that volume for a sphere is a little bit different. 4 pi r cubed. Do you all have that formula written down? Four pi r cubed and then divided by 3, so a little bit different in both those ways. Because the other one we didn't divide by anything. Okay, I see people working ahead, and that's fine. So the first one, the radius is 8. 4 pi 8 cubed divided by 3. Remember that your cubed button, like taking something to the third power, you can do 8 times 8 times 8. But there's a little button that looks like a little arrow. It's called a little caret. It's on the left column somewhere by the square root. And if you type in 8 with the little caret and then 3, that means 8 to the third power. Some calculators even have a cubed button. But you should know that button because next year you're going to start taking numbers to higher powers. So if you take something to the 12th power, you're probably not going to want to type in 2 times 2 times 2 over and over and over again. All right, what is 8 cubed? What is it? 512. Okay. 512 times 4 divided by 3. 512 times 4 divided by 3. Divided by 3 is 682.6 repeating pi. Okay. And that's not terrible. And it is a 0.6 repeating, even though your calculator puts a 7 at the end. Whoa, sorry. I blew out on my hand. Sometimes I don't know my own strength, sorry. Even though there is a 7 at the end, there's not actually a 7 at the end. Your calculator rounds the last number for whatever reason. It's 0.6 repeating, it's 2/3. And then that's just really not good notation mathematically, and that's an advanced thing to think about. But you don't want to mix repeated decimals and irrational numbers with other irrational numbers. It just doesn't, we just don't write it that way. So we would rather you just type in times pi and get an overall decimal than to write it like that. I would accept either on a test, but I mean it's multiple choice, so you'll it's good, it's a fine question. Multiple choice, you'll have to figure it out. Okay, last one. What would the radius be here? Who can raise their, let's go with, I've heard from the same people. Let's go Delaney. What would the radius be on V? 11, because the diameter is 22. So then type all that in. Everybody type that in so that we can all be on the same page. And go ahead and type it in times pi too.
So you want the answer?
I want the full decimal answer.
On the homework, yeah?
It doesn't really matter on the homework. And let's go. Petra, what are you getting here?
For 11 cubed times 5 times 4.
And then divided by 3.
Oh, 5,570.
We're not getting that number. It doesn't know where it came from. Said I need to break it down more. 11 cubed is 1,331, then times 4 times pi divided by 3.
So they're pretty big numbers, right?
It just depends. I mean, that's a pretty big radius, 11. So if your radius is 2, that's going to be a smaller number. But yeah. I know, like, the bottom ones on there are big numbers. Okay. So the rest of the time is for you to work, but I do want to bring up something. Oh, your worksheet, by the way, says 12.6. It's not actually 12.6. That's from the old book. So that's going to be our 11.8. It's really squished together, but you can use the back page to show work if you like. Now, I wanted to bring up numbers 10 through 13. You have to read the directions to do the problem. If you don't read the fact that the circumference is 9 pi, then you're never going to be able to find the radius. One second. And then on the bottom it says find the surface areas of Earth and Mercury, and I'm pretty sure those are fairly accurate measurements when I looked this up years ago. But then it says something about comparing it. Don't worry about comparing it, just find the surface areas and then you'll be fine.
Is that the radius or the diameter?
Radius.
Do you know you get questioning if the Earth is square?
We've been questioning that for years.
Earth is flat.
Wait,
What? I don't know. I'm not an astronaut.
well, like, but in space,
It's geometry.
I don't know.
it's calculation.
It's just the Earth is flat.
You think it's geography?
The Earth is flat. Okay, you're right. The Earth is flat.
You good?
You think so?
Well, how come, like, if they say, like, if helicopters were hovering in the air forever, that they're just saying, how come